So we're looking at how much energy is needed to heat 300 grams of water at negative 75 degrees Celsius to 55 degrees Celsius. So we're solving for energy, which is Q. 300 grams is our mass. Negative 75 is the temperature, and then 55 degrees is a temperature. So what we're going to do is create our graph again. And we're going to mark our negative 75 degrees Celsius and our 55 degrees Celsius. And then we're going to look at our melting and boiling point of water. So 0 degrees Celsius will fit in here, but 100 degrees Celsius won't. So we're going to draw our straight line, and next I need to connect my two temperatures, but I don't know if I want to connect them up or downward. I need to see what's happening. So we're heating the reaction, okay? So it's a positive, it's an endothermic reaction, you're gaining, which also tells us our answer is going to be positive. So we're going up, okay? This is when it is heating up, so it's melting. So this is B, this is when it's solid, this is when it's liquid. So that weird, liquid. So we have A, B, and C to solve. So let's start with A when we're in our solid phase, which is Q equals mass times the specific heat of a solid times the change in temperature. So our mass is 300 grams. Our specific heat of a solid, which you can look up, is 2.06 joules per gram degrees Celsius. Our change in temperature is 0, our final, minus negative 75, which is our initial, which gives us a positive 75 degrees Celsius. If we multiply that together, we'll get 46,350 joules. I want my answer to be in kilojoules, so I'm going to move that decimal over, and I will get 46,300, no, wait, 35. Sorry guys, messed that one up, and it looks awful. So it's a 35 kilojoules. Okay, moving on to part B, we have Q, and in here we're melting. So we're going to use the heat of fusion times N, which is our number of moles. Heat of fusion for water is 6.02 kilojoules per mole. N is our number of moles, so to find our number of moles we do 300 grams. Water over 1, using that stoichiometry to convert my grams into moles. 18 is the mass of water, and that's going to give us 16.67 moles. I'm going to multiply that together. I'm going to get 100.35 kilojoules. Okay, and then lastly, we're going to do part C, which is Q, and we're looking at our liquid, so mass times specific heat of a liquid times change in temperature liquid. Should put an S up there. So our mass, we want again, is 300 grams. Our specific heat for a liquid, if you look it up, is 4.187 joules per gram degrees Celsius, and our change in temperature is 55 minus 0, so 55 degrees Celsius. You multiply those three together, we're going to get 69,085.5 joules. I'm going to move that decimal over 3 spots. I'm going to get 69.09 kilojoules. Okay, and then lastly, to get our Q total, I'm going to add those three numbers up, 46.35 kilojoules plus 100.35 kilojoules. And this is actually why we had to convert everything to kilojoules, because unlike multiplying and dividing, when you can do that with different units, adding and subtracting can only be done when units are the same. So if we add those all together, we're going to get 132.11. Oh, wait. Sorry, my addition is wrong there. Let me do that. So we have 46.35 plus 100.35 plus 69.09, and we get 215.79 kilojoules. So that is my final answer.